Children, let's see now what is cyclic quadrilateral, and there are many theorems, properties of cyclic quadrilateral. One by one is what we shall see. Before I start, I would like to say once again, all the theorems, right? We are not solving the way in which I want all my children, because every board has given in their textbook, whatever reference book you refer to, there are theorems. Main thing is what students don't understand the theorem, right? We are here to understand, refresh our concepts in a totally different way, reinvent learning. That's what we are for. So this is also we are going to understand via skeletal. Now you should be very much familiar with the word skeletal, right? First of all, let's understand the meaning of the word cyclic quadrilateral. You all are aware about quadrilateral, right? Quadrilateral is nothing but any four-sided figure. But what's a cyclic quadrilateral? Cyclic quadrilateral is that quadrilateral where all the four vertices of a quadrilateral lie on the circumference of the circle. What's a cyclic quadrilateral? A quadrilateral in which all the four vertices lie on the circumference of circle. Can I say the given figure quadrilateral ABCD is any random quadrilateral? I have not drawn any specific rectangle, parallelogram, square, rhombus. No, it is a random quadrilateral. Are all the four vertices lying on the circumference? Therefore, it's a cyclic quadrilateral. This is the definition of cyclic quadrilateral. What is the first one? What is the very first and the utmost important property of cyclic quadrilateral? Utmost important property. Having understood what is cyclic quadrilateral, the first property, opposite angles of cyclic quadrilateral are supplementary. Opposite angles of cyclic quadrilateral are supplementary. So what we need to prove, opposite angles are supplementary, opposite angles of cyclic quadrilateral, or I'll correct it, one pair of opposite angle. Let me correct it. One pair, so that you can understand in a better way. When I say pair of opposite angle, one pair of opposite angles. When I say pair, that means I'm talking about A plus C. When I say pair, I'm talking about B plus D. So you need to prove any one. Similarly, we can prove the second one. So I shall say over here, it is angle A plus angle C is 180. Supplementary means 180. Supplementary means 180. Angle A plus angle C is 180. Now children, just in the previous video, when we had learned IAT, inscribed angle theorem, we learned two versions. One was talking in terms of central angle. One was talking in terms of inscribed angle. Here also, I am going to give you two answers. One in terms of intercepted arc. Sorry, I went wrong. One we learned in the term of central angle, and one we learned in the term of intercepted arc. Here also, we are going to learn one answer in the form of intercepted arc. That is, we are going to apply IAT, but in the form of intercepted arc. Here also we will be applying IAT, but in the form of central angle. So both the solutions are going to be the same. Mind you, whatever board you are into, whatever solution is what your board accepts is what you are supposed to take it. I repeat, it is up to your board which board you are into, and whatever solution they accept is what you are going to take it. We start. So it is A plus C is 180 is what we need to prove. You could have done with B plus D also. Now I am taking first the answer as intercepted arc. I am taking the answer as intercepted arc. We start our sum now. What is DAB? What kind of angle DAB is? Sir, it is formed on the circumference of a circle, so it is an inscribed angle. DAB is an inscribed angle. And what type of arc? Arc DXB is. Arc DXB is an arc DCB. I'm sorry. DCB is an intercepted arc. Once again, What type of angle DAB is? It is an inscribed angle. What type of arc DCB is? It is an intercepted arc. Did we learn something called as inscribed angle is half the intercepted arc? So can I say angle A in a very short way? Angle A is half of measure arc DCB. Inscribed angle, half of intercepted arc. Equation number 1. On the same lines, what is angle C? DCB. Angle C, which is DCB, it is also an inscribed angle. And what is its intercepted arc? DAB. Because it is arc DAB which is forming an angle C. Also, angle C is half of measure arc DAB. This is my equation number 2. Now in the previous video only, in the previous slide, what I asked you, always ask question to question. Now asking this particular question, what you want? And the question answers me, I want A plus C. The question says I want A plus C. That tells me I need to go for addition of 1 and 2. Why? Because then and then only I'll be getting A plus C. Then and then only I'll be getting A plus C. So what I shall be writing, adding equations 1 and 2. When I add equation 1 and 2 on my LHS, I'll get angle A plus angle C. On my RHS, I shall get half measure arc DCB plus half measure arc DAB. Am I right, children? Angle A plus angle C as it is. Can I say half common? Can I say half common? What is measure arc DCB plus measure arc DAB? I want, children, you to understand and tell me what is DCB plus DAB. DCB plus DAB is nothing but entire circle. DCB, DAB is nothing but entire circle. And what is the angular measure of a circle? Angular measure of a circle is 360. What is angular measure of a circle? Angular measure of a circle is 360. So can I say angle A plus angle C is half of, and besides the reason, angular measure of circle. Angular measure of circle. Angular measure of circle. Half 1 2 A plus C is 180. Very simple, children. Very simple. So this was in context to what? This was in context to intercepted arc. Inscribed angle is half the intercepted arc. A half of DCB, C half of DAB. Add them together, A plus C, arc DCB plus arc DAB. That is nothing but entire circle. Divide by 2. Let's go and understand the other way around. In context to what? Central angle. In context to what? Central angle. So our proof starts now. For central angle, I have to join DO and BO. O being the center of the circle, I will join DO and BO. Let's start. So what did we study in context to central angle? Inscribed angle is half the central angle, or central angle is double the inscribed angle. Whatever you want, you can take it. Inscribed angle is half the central angle, or central angle is double the inscribed angle. Can I say angle A is half of angle DOB? DOB. Inscribed angle is half the central angle. Everywhere you will write down the reason. Here also I haven't written down the reason, children. I haven't written down the reason. Here also, as I said, we are writing skeletal solution. Though I'll be saying every reason, I shall be saying every reason verbally. You have to write down. ligaments, tendons to get a complete structure, right? So angle A, half of DOB. What is the reason? The reason is inscribed angle is half the central angle. Likewise, also, what is angle C then? Angle C is half of. Now, if this is DOB, children, if this is DOB, then this is also angle DOB, but it is not termed as angle DOB, it is termed as reflex angle DOB. In a circle or at the center, in a circle at the center, if you have only two angles, one angle and the other are reflexes of each other. So if this is angle DOB, this is termed as reflex angle DOB. This is angle DOB, this is termed as reflex angle DOB. So what I'm going to write down over here, angle C is also half of, but this time angle DOB we cannot say, we have to use the word reflex angle DOB. Angle C is half of reflex angle DOB. Are you getting me? This is equation number 2. Once again I ask question. What you want? And the question says I want A plus C. That tells me adding equation 1 and 2. You can compare also simultaneously. It is absolutely the same, but one is talking in terms of intercepted arc. One is talking in terms of central angle. Both have common inscribed angle. I think now the picture is getting very, very clear. If it was murky till now, gloomy till now, now the picture is getting very crystal clear. Adding equations, mind you, adding equations 1 and 2, what I shall get? Angle A plus angle C on the LHS part. On the RHS part, half of DOB plus half of reflex angle, I'm just writing reflex angle DOB. Half common A plus C, half common DOB plus reflex angle DOB. Children, a angle and its reflex angle summation is always 360, right? An angle and its reflex angle summation is always 360. Angle A plus angle C is half of, summation is always 360. Same lines, ones are 180s are, what I'm left with, angle A plus angle C 180. Angle A plus angle C 180. IAT with in context to intercepted arc. Again IAT in context to central angle. And main thing, we need to remember what have we proved. So don't forget what have we proved. Our first property and the utmost important property of cyclic quadrilateral. One pair of opposite angles of cyclic quadrilateral are supplementary. In fact, both the pairs. So you can't say only one pair. If those who are thinking that it's only one pair, let me once again correct myself. Actually, it is always written as opposite pair of angles of cyclic quadrilateral are supplementary. If you want to write down the statement, it is opposite pair of angles of cyclic quadrilateral. Pair of angles of cyclic quadrilateral are supplementary. So you can say A plus C is 180. At the same time, you can always say B plus D is also 180. Though we haven't proved, but I can say similarly we can prove. Similarly, we can prove B plus D is also 180. B plus D is also 180. Right? Very, very, very important property of cyclic quadrilateral.